Hey guys, this is Coach Brian finishing up the 7.4 notes. Just a reminder, 7.4 is about special triangles, 45, 45, 90 triangles, also known as isosceles triangles. And we are, in this part, working on the back of the notes. Excuse me. So in these two examples, we have two triangles, and we are trying to find the missing sides. It says to draw a chart each time, rationalize the denominator. So when it says draw the chart, it's talking about this kind of chart right here that we were doing up in example 1. And, excuse me, we are specifically looking at our angles and sides. All right, so we have angles A, B, and C. And we have sides, I'll just go across from them. We have BC, we have AC, and we have AB. Those are our sides. And so just looking at, nothing else except the markings on the picture, we know we have a 90-degree angle, and then we have two sides that match. And so this is an isosceles right triangle, or a 45, 45, 90 triangle. And now, as soon as we know we have a right triangle, we know the Pythagorean theorem applies. And in this case, they give us the hypotenuse, which is 12. Okay, so that side AC is 12. And that's helpful for finding the missing sides. And so we have two sides. We know that they're the same because of these marks. And so let's just say, just for the sake of using a variable, let's just say that they're both x, okay? So if I was plugging this into the Pythagorean theorem, x squared plus x squared equals 12 squared. So x squared plus x squared, if I have a variable like this with nothing in front of it, it's understood that there's a 1, okay? It's understood that there's a 1 in front of it. And so I have 1x squared plus 1x squared. Guess what? That's 2x squared. And then 12 squared is 144. And so at this point, I just start solving algebraically. So I'm going to divide by 2. X squared equals 72. Next thing I need to do is find the square root of both sides so that those cancel. And 72 is not a perfect square. And so I would just see if I could simplify it. And the square root of 72, 2 and 36. Okay, so I instantly see that 6 is a perfect square. It's going to break into 6 and 6. I'm going to cross one out and kick one out. That leaves me with 6 square root of 2. So both of my sides here are 6 square root of 2. On our next example, they do give us one side, and we have this marking indicating that the other side is congruent. So we know that this one's also 5. And we can just label our angles A, B, C. Doesn't really make a difference what's what. And we can create our chart. So angle B is our 90. We know that for sure because of how it's marked. And since this is an isosceles triangle, we know the other two angles have to be congruent. And if they have to be congruent, they have to be 45 degrees each. And then our sides are BC, AC, okay, and AB. So as we're calculating our sides, we have our A and our B, and we're looking for C, our hypotenuse. So A squared plus B squared equals C squared. 5 squared plus 5 squared equals C squared. 5 squared is 25. 5 squared is 25. Together, C squared equals 50. Now I have to get rid of the the power. So I'm going to use a root, and I got to do it to both sides. So C is the square root of 50. I'm going to split this into 2 and 25. I recognize that 25 is a perfect square. It's going to split into 5 and 5. I can cross one out, kick one out, and I'm left with 5 square root of 2. That is our missing side length, 5 square root of 2. Now, if you look, both of these kind of match this pattern that we established up here in example 1, where when the sides are the same, the hypotenuse is just that side length, square root of 2. And so the one we just did was like this one, 7 square root of 2. This one was 5 square root of 2. Just a little pattern. All right, a couple more examples left. Example number 4. The perimeter of a square is 44 inches. Find the length of the diagonal. So a square has 4 congruent sides. 4 congruent sides. So they would all have a mark on them that shows that they're congruent. And if the perimeter, that's the all the way around, is 44, that means to find each side, I need to do 44 divided by 4 sides. And so each side of my square is 11 inches. Now, what I'm actually looking for is the diagonal. So I'm looking for the hypotenuse of the right triangle that's created when you draw a diagonal line dividing this square. And so now I move more into the multiplication side of things, all right? A, B, C. A squared plus B squared equals C squared. Specifically, when I'm looking for C, I like to write it as C equals the square root of A squared plus B squared. And so if I'm solving for C and both of my sides are 11, 11 squared is going to give me 121 plus 121. And so that equals the square root of 242. 242 is not a perfect square. So I want to see if I can simplify it. I think you'll notice another pattern here. I can split 242 into 2 and 121. 121 is a perfect square of 11 and 11. Once I have 2 matching factors, I can cross one out and kick one out. And so this equals 11 times the square root of 2, which again follows the same pattern as question number 3 and a lot of the examples in example number 1. So 11 square root of 2 is the distance diagonally across the square. Example number 5 works in a little bit different direction. It says the diagonal of a square is 13 times square root of 2. This one, I feel like we're getting to the point we could not do any math and have a good idea of what it is just based on the patterns we've been seeing. But let's confirm. Okay, we're trying to figure out what these two sides are. And it's a square, so we know they're all equal. We know it's a square because it says so in the question. So we know all the sides are going to be the same. And we also know that all the angles in a square are 90. So this gives us a 45, 45, 90 triangle. Now in this case, we have C and we don't know the sides. So if we were to write out A squared plus B squared equals C squared, we would get that we don't know A, so we'll just call it X. We don't know B, but it's the same, so we'll also call it X. And then we have 13 times the square root of 2 squared. If I have if I have a number like this, a mixed radical that's squared, I actually end up distributing the exponent. And so what this equals would be 13 squared times the square root of 2 squared. And 13 squared is 169. The square root of 2 squared, those just cancel, and I'm left with 2, the radicands. On this side, I have x squared and x squared, and when I add those together, I get 2x squared. And so I already see right here, I have a 2, and out front here, I have a 2. So if I just divide both sides by 2, those will cancel out. And so what I'm left with is x squared equals 169. And if I find the square root of both sides, x is 13. Both of these equal 13. And that actually, again, fits this same pattern that we've seen in the last couple of questions. Last example, this is a multi-part question. And we are solving for a ramp that makes a 45-degree angle with the ground that is 6 feet from a loading dock. And then our final answer needs to be rounded to the nearest hundredth. So that's going to be 2 decimal places. So the best thing to do in these situations is usually to draw a sketch, okay? Right now, we have a loading dock. So first, you have to know that like a loading dock is usually on a building, and it's the little like part where trucks back up to so they can unload supplies. Now, if we're loading things in this building, we need to have a ramp. Sorry, my first drawing of that ramp wasn't so good. Let's clean that up. We need to have a ramp. And that ramp's going to be on the ground. And it gives us 2 important pieces of information about this ramp. One, the angle it makes with the ground is 45 degrees. Now, we also know that the angle it makes with the building is 90, assuming that this building was built with straight walls and that the ground at that point is flat. And the other key piece of information is that the distance from the dock to the ramp, the horizontal distance, is 6 feet. Excuse me. So, draw a picture of this situation. Done. If I'd have read the question before, I could have drawn it in the correct spot. I'll sketch it again real quick. there's our situation. The loading dock and the building, the 45 degrees, the 6 degrees from the building. How high does the ramp reach? So what we're looking for is this distance here. How high does it reach? Now we do have some clues that like, hey, if this is 45 and this is 90, then this has to be 45. And if these are a 45, 45, 90 triangle, then these sides have to be the same. So our answer should be 6. Let's confirm though. I have a triangle. Oh, that's horrible. I have a triangle, 45 degrees, and 6 as one of the sides, 90 as the other angle. Yeah, it's a 45, 45, 90 triangle. So, isosceles. The ramp goes up 6. Next question, how long is the ramp? So this distance right here. Based on what we've been seeing and the patterns that we've been seeing, should be 6 times the square root of 2. Let's confirm. I have a triangle where the sides are 6 and 6. I want to know how long the actual hypotenuse is, in this case, the ramp. And so if I'm solving for C, it's the square root of a squared plus b squared. And in this case, it's the square root of 6 squared plus 6 squared, which is 36 plus 36, which is 72. C equals the square root of 72. And so I need to simplify that, split it into 2 and 36. 36 is a perfect square, so I put a square around it. It splits into its factors. I have 2 6s, so I can cross one out, kick one out, and I'm left with 6 and the square root of 2. That is my final answer. Hopefully this was helpful for you guys, and I will see you in the next video.